Hey there, MSM3. We are here today to talk about square roots. Students will be able to identify perfect squares, then find the square roots of various perfect squares, including fractions and decimals. Students will be able to use inverses to solve one-step equations involving square roots. So, makes sense that a square root has something to do with a square. Since we know that the area of a square is equal to s squared, this is an equation that we used for geometry purposes last year. We can also talk about what if we know the area and we don't know the side length. So most of the time last year, we would give you the side length and ask you to find the area. Well, what if I tell you that the area is 36 inches squared and ask you how long one side is? Well, what number times the same number would give you 36? So the value of x in this case would be 6 inches because 6 inches by 6 inches would be 36 square inches. So how do you find the value of x? What you do is take the square root of 36. And that's what that symbol is. That symbol is called a radical. In order to take the square root, you are finding two of the same number that would multiply to give you 36. Algebraically, we would first write the formula, a equals s squared. Then we would fill in the information we know. We know that the area is 36. So we know that 36 has to equal s squared. Now, the inverse of squaring is square rooting. The inverse of square rooting is squaring. So if we need to undo this little 2 up in the corner, which is read squared or to the second power, we would need to square root both sides of the equation. Whatever we do to one side, we have to do the same to the other side. And we would get that 6 equals s. We are talking about a length, so obviously the answer would have to be positive because all lengths are positive. So we have to find the square root of a number. You need to determine what numbers can be multiplied by itself to get the number that's under the radical. That symbol is called a radical. And you must know the first 16 perfect squares. A perfect square is a number whose square root comes out to be a whole number. So when you use a calculator and you take the square root of something, the answer needs to have no decimals, no fractions. These are the first 16 perfect squares, which it is expected that you will memorize. Not like today, but in general. Find the following square roots. So this says the square root of 100 equals what number times itself would give us 100? And that number is 10. It also happens to be the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th perfect square is 100. So that means the square root of 100 is 10. 169 is the 13th perfect square, which makes the square root of 169 13. So notice the answer is no longer under the radical because we have done what that symbol asked us to do. This one is asking us to find the opposite of the square root of 9 or the negative square root of 9. So we're only in this case finding the negative answer. And some of you might be like, what do you mean? Well, negative 3 times negative 3 is equal to positive 9. So you can have a negative answer as well. The negative square root of 81 or the opposite of the square root of 81 would be negative 9 because negative 9 times negative 9, negative times a negative, gives us the 81 that's under the radical. So when there's a negative sign in front of the radical, it means give the negative answer only. If you see a plus or minus sign in front, we're looking for both the positive and negative answers. If you see no sign, then they are typically looking for what is called the principal square root, which is the positive one only. So if you see the plus or minus sign, the square root of 225, it is the 15th perfect square, would be plus or minus 15, meaning there's two answers. 15 times 15 will give me 225, and negative 15 times negative 15 will also give me 225. So plus or minus the square root of 144 is plus or minus 12. And then what if we have a fraction under the radical? All we have to do is take the square root of the numerator and denominator individually. The square root of 25 is 5. The square root of 100 is 10. And then check to see that it's in lowest terms. 5/10 is the same as 1/2. The square root of 81 over 225 would be 9 over 15. And in lowest terms, that would be 3/5. Always have to check that it's in lowest terms. Now, when we look at the back, you're going to notice that we have some large numbers, and you're thinking to yourself, how do I find the square root of 81 million? Well, if it's a really large number, find the perfect square and take the square root of that. This will be at the beginning of your answer. So you'll notice that this number starts with 81, and 81 was on our list of perfect squares. So if we just start, sorry about that, by taking the square root of 81, we get 9. That's how you start the question. Then it says take half as many zeros as there are in the number. So when I look at this, this has 6 zeros, so I'm only going to put 3 zeros in my answer and I would be done. We're also going to assume this was looking for the principal square root since there was no symbol in front of it. The square root of 900. So if I look for the square number at the beginning, 9, the square root of 9 is 3, and then I only want half of the zeros, which would be 1 0. So this trick, this sort of shortcut, only works if two things happen. You have to start the number with a perfect square, and there has to be an even number of zeros following it. If you have a decimal, you're going to do the same sort of activity, same sort of idea. You're going to look for the square root, the number that is a perfect square. In this case, it's 49. Now, notice where I'm putting my 7, right? Because the square root of 49 is 7. 7 times 7 is 49. This one, it says take half as many decimal places. So it's slightly different. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 decimal places. That means my answer needs 4 decimal places after the decimal point. So you put the 7 at the very end. Any of those other spaces you fill in with zeros so that your answer has 1, 2, 3, 4 total places after the decimal point. So this is 0.0007. Same shortcut can be done over here, 196. The square root of 196 is 14. So I'm going to put 14 way over here at the end. 1, 2, 3, 4, 5, 6. This number has a total of 6 decimal places. So I need 1, 2, 3 in my answer after the decimal point. The 14 goes all the way to the right, and any spots left over get filled in with zeros. So 0.014, total of 3 digits after the decimal point. The other way that square root can be written is with an exponent of 1/2. So 64 to the 1/2 means the same thing as the square root of 64, which is 8. 256 to the 1/2 power means the same as the square root of 256. And the answer to that is 16, also principal square roots. Is it possible to find the square root of a negative number? For example, can you do the square root of -9 or the square root of -100? Now notice this time the negative sign is inside the radical. That is different than what we had on the front of the notes. Can you find 2 of the same number that multiply to get -9? Can you find 2 of the same number that multiply to get -100? The answer is no, not with the real numbers we're using currently. So 2 of the same number will always have a positive product. All right. What would you give for an answer if you were asked to find the square root of a negative number? Well, you wouldn't just be like, nah, I can't do that. There's got to be an answer. And the answer is the word undefined. We cannot define the answer to the square root of a negative number. So the square root of -100, the answer is undefined. The square root of -9, the answer is undefined. And then we've got at the bottom some of the equations. And they're equations. I know they're equations because they have an equal sign with stuff on both sides. I also can see this one has squared, x to the second power, x to the second power, y to the second power, z to the second power. All of these questions have a squared and exponent in them. So in order to solve, we're going to solve by using the inverse of that operation. So this one has squared. The inverse is to find the square root. So what I have to do is the same thing to both sides, square root of x squared and square root of 144. The answer is x equals plus or minus 12. Now remember on the front, we only use the positive answer because we were talking specifically about a length of something, an area of something. We were talking about geometry where things are only positive. Now, this equation is not specific to some sort of geometry question. So there are technically two answers. 12 times 12 is 144. Negative 12 times negative 12 is also 144. So on each of these, we're going to square root both sides. X equals plus or minus, and the square root of 400 is 20. Y squared, so we're going to square root both sides, and we would say plus or minus 15 equals y. The better answer, remember, is to start with the variable, so it's better to rewrite it as y equals plus or minus 15. And then we have one last question there. Z squared equals negative 4. We would square root both sides, and we would say that z equals undefined. Why? Because we were trying to square root a negative, and we do not have the ability currently with real numbers to square root a negative number. Last but not least, what if the equation already has the radical in it? Well, the opposite of squared is square rooting with the radical. So if this equation has the radical in it, we're going to do the opposite, which is to square both sides. You do need to use parentheses, and I'm going to square both sides. The radical and the squared cancel each other out, and you have x equals, and what do you get when you do 9 squared? 9 times 9 is 81, only one answer. Square root of x equals 30. So the inverse of square rooting would be to square both sides. X equals 30 times 30 is 900, only one answer. Last but not least, on the right, we have the square root of x, so we're going to square both sides. 0.6 times 0.6, just so I can convince you. If you do 6 times 6 is 36, you have to remember to move your decimal point over 2 places, and it is 0.36. So 0.36 equals x, only one answer, and we would always rewrite that so the variable is on the left. X equals 0.36 as our final answer. Now, for the video check-in, grab yourself a piece of paper, post-it note, grocery list, something like that, and you have 2 questions for today. The video check-in is asking you to find the opposite or the negative square root of 144 million, and you're going to then write down the answer, and to solve the square root of x equals 81. And yes, I want you to show your work after you copy down the question. Can't wait to see you guys in class. Bye.